Hello everyone, and welcome to today's webinar called Machine Learning in Retail Supply Chain and Merchandising. I'm Debbie House, Editor-in-Chief of Retail Touchpoints, and I'll be moderating today's presentation. We're honored to be joined today by Kevin Stadler and Stefano Alberti from 4R Systems, who will share insights into how retailers can use advanced analytics and machine learning to increase the bottom line. This webinar is the fifth in a series of 10 presented as part of the Retail Touchpoints 2017 Retail Strategy and Planning Series. During this series, attendees have the opportunity to hear from leading industry experts who are discussing the most important topics on retailers' minds today. By registering for one session, attendees have access to all complimentary presentations, both live and on demand. We also welcome you to follow this and all other Strategy and Planning Series webinars on Twitter using the RSP17 hashtag. On this slide, you'll also find the Twitter handles for Retail Touchpoints and 4R Systems. We're also hosting a special sweepstakes throughout the week-long series where attendees can win a free ticket to our annual Retail Innovation Conference in New York City, which is taking place May 1st and 2nd in 2018. By registering for the series, you've earned one entry, and by attending today's session, you're receiving a second entry. Throughout the series, you can earn one entry for each RSP webinar you sign up for, and an additional entry for each session you attend live. We'll be giving away a total of 5 free tickets, and we'll be announcing a winner each day of the series, so be sure to stay tuned in all week for your best chance to win. For today's presentation, we're using the On24 platform. So right now, you should be viewing the On24 dashboard, which shows the live viewing screen. By clicking on the Questions widget on the right-hand side of the screen, you can type in questions during the live presentation and press Submit. You'll also find a widget named Resources under Questions, and there you can download assets our presenters have provided. All you have to do is click on the resource and it'll automatically download. If you're not able to attend one or more of the sessions, they're all available free to all registrants. You can access them on demand at your convenience. To learn more, you can go to the Retail Touchpoints website. That's www.retailtouchpoints.com. In addition to joining the conversation online and submitting your questions on the On24 platform, we'd also like to welcome and encourage you to participate by letting us know how we're doing with our webinar series. We want to constantly improve the level of value we provide to you, our session attendees, so we've put together a very brief survey that will automatically launch once the session concludes. You also can complete and submit the survey by clicking on the survey icon in the taskbar on the bottom of your screen. The survey icon is circled here in red on this slide. So before signing off today, please take a moment to complete the quick questionnaire. We appreciate and value your feedback and look forward to hearing from you. For those of you who might be new to Retail Touchpoints, here's a very quick overview. We're an all-digital media company publishing a weekly email and online newsletter, daily news, special reports, and multimedia presentations. If you haven't done so already, please subscribe to our weekly newsletter. And we welcome input and feedback through traditional means, phone and email, but also social media, LinkedIn, Twitter, and Facebook. And once again, our website is retailtouchpoints.com. Before I introduce today's speakers, I just want to remind the audience the presentation is slated for approximately 30 minutes with time for live questions at the end. We invite you to submit questions in the On24 questions area as they come to mind. Our presenters have agreed to stay online following the presentation to respond to your questions. I also want to point out a few other housekeeping items for the attendees. Again, the webinar is being recorded and all attendees will receive an archive link to the presentation to go back and review or share with colleagues. In addition, the slides will be posted to SlideShare. So our first presenter today is Kevin Stadler, who's responsible for the continued strategic expansion and overall operations of 4R. Kevin has more than 25 years of experience in retail technology, product strategy, sales, and software design. Prior to joining 4R, he was CEO of Intactix International and was also the CEO of Standard Analytics. Earlier in his career, he developed AI programs in Prolog and OPS5 for McDonnell Douglas. And we'll also hear from Stefano Alberti, who joined 4R Systems in 2002 and brings expertise in forecasting, statistical data analysis, algorithm development, and price optimization. Prior to joining 4R Systems, Stefano was a lead analyst with Manugistics, where he led the algorithmic development of one of Manugistics' pricing optimization products from conceptual prototype phase to successful installation. While at Manugistics, he also consulted and designed revenue management systems for travel and transportation industry clients. So with that, I'm going to turn the presentation over to Kevin.
Thanks, Debbie. I'd like to introduce the topic for today. It's obviously something that's receiving a lot of buzz in the industry right now. And what we would like to accomplish more than anything is to give you just a little bit of backdrop about advanced analytics, machine learning, and how it can affect the retail bottom line in a fairly significant way. As you'll find out as we go through the presentation, we've delved into this quite a bit, use it quite a bit at 4R, and would like to pass on some of those learnings to you. Stefano and I will take you through a number of different ideas, pitfalls, and a prescriptive guide to how you can learn how to move forward with machine learning. We're going to talk specifically about machine learning techniques and approaches, give you a couple of real-world learnings and examples. Hopefully some of those you will find humorous, and then a little bit more about best practices, what works and what we have found, what doesn't work, so you don't have to go through the blind alleys and can get right into the meat of machine learning. Topics for today. First off, a little bit backdrop as to why in recent history this has become such a hot topic. Challenges and pitfalls with the topic of machine learning. Best uses in retail, because this is not something you want to apply absolutely everywhere, but there are some really good sweet spots inside of retail process. The concept of supervised learning and model enhancement, and examples specifically of pattern recognition, learning, and how to actually take action off of the models once you've developed them and use them to connect into operational practice. And then last, just a little bit of advice on crawl, walk, run in terms of machine learning. It's not something you want to jump into right away at a full throttle. It's something you want to learn bit by bit and actually take advantage of the low-hanging fruit before you move forward. So the first question in many ways is, why now? Why is machine learning such a hot topic in retail? As Dr. Marshall Fisher from the Wharton School has indicated many times to us, if you look at retail, it's a data production factory. The concept of big data is not foreign at all to retail, and it's accelerating at an extremely fast pace. If you look at the introduction of more and more social networking techniques, mobile, omni-channel, you name it, the instances of data continue to multiply. The second is the concept behind why is machine learning something which is particularly useful when you've got that much information. And at its core, machine learning is based on the assumption that a relatively simple model with a small number of hidden factors in their interaction can explain and predict outcome. And this is particularly useful in retail when you have that much data and it's so hard to look through, and retail changes so fast. In particular, it's useful in retail in a number of areas where behaviors can change quickly. If you look at the concept of recommendation engines, personalization, seasonality and promotion, to where fads and trends are increasing at an ever faster and faster rate, personalization and how you achieve that is something that the last two factors can actually help you with. However, and we're going to point out this, that in a number of different ways, so hopefully you don't encounter some of these pitfalls, the supervised and unsupervised learning in retail is possible, but you need to be careful on how you use it. In a quick word, supervised learning has, in essence, goals and guardrails. People historically have called supervised learning backward chaining, and what that means is you're looking for a certain outcome and providing guide rails on what the machine learning is doing, as opposed to it being able to do, in essence, forward chaining, which is the opposite approach, which is to go through all of the data and come up with its own conclusions. I think you'll find supervised learning in retail is important, and it's something that you should subscribe to. So let's talk a little bit about, kind of the pitfalls and some of the challenges here. Many times in information technology, you've heard the phrase garbage in, garbage out. It's a little bit more exacerbated when you get to machine learning because it's garbage in and flawed learning. What happens is that if you have bad information on the inbound side, the machine learning creates false conclusions and false models that aren't actually predictive of behavior. So that's number one, is to make sure that the information is correct on the way in. Second is, the more history, the better. Specifically with what machine learning is looking for, patterns repeat over time. And the more time that you have, obviously, the more patterns that can be detected, regardless of whether it's a current trend or not, is not as relevant as finding the underlying pattern. Third is using as much causal data as possible. Tradition inside of retail has been to use just certain causal factors, price, promotion, certain pieces along with that. We'd say inventory history is important, market basket is important, customer IDs, demographics, all important relative to understanding what are the causal factors, and there's many, many, many more past that. And the last pitfall, of which I'm going to give you a couple of examples, is that underlying core is that machine learning is at its essence dumb, and it needs to be watched or supervised. A couple of examples. We're working with one client, and machine learning comes up with what we call the $5 platinum brick. You look at all of the attributes, and in theory, a $5 platinum brick would sell exceptionally well. That said, if anybody looks at that in any detail, they'd find out that the cost far exceeds what the actual amount that you could sell it for is in order to achieve that. And without a defined goal in mind, meaning profit, it makes a bad conclusion, hence the $5 platinum brick. Unless you're Amazon and you can sell things below cost and not have to charge for shipping, this would be a bad conclusion. Second is the concept of how things are actually attributed and how you define them. An example here is too many flavors of chocolate means chocolate is unpopular in machine learning. True life example is that we had a product category, and there were many, many, many different spellings of chocolate. Dark chocolate, milk chocolate. Sometimes it was CHK. Sometimes it was CHK with sea salt, et cetera, et cetera. Same thing occurred with vanilla. So you had many, many instances. Machine learning looks at that, looks at each individual and says that's not the same as the other one. And the conclusion that came up in this example was that strawberry was the best flavor to attribute to increase assortment. Obviously false. And I think we're going to talk about a little bit later is normalization of data is important when you get into machine learning. Next one is a concept of machine learning doesn't really understand the underlying construct of what's going on. An example of this one is one we saw where St. Patrick's Day t-shirts and the trends were a mystery to machine learning. In the item description, it basically was STP t-shirt, and no link to end of life, no link to it was a calendar type of a thing. And machine learning basically would look at a St. Patrick's Day t-shirt without any additional causal data or any additional link information, and would establish the fact that this would sell well weeks following St. Patrick's Day, thereby chasing very bad trends. So you do need to understand when you look at items with seasonality and you look at items that are unique to either link them to the attribute or link them to the actual calendar event and understand what's causal within it. Last, in terms of the items that I'm going to talk about with pitfalls, is the idea of sparse data. If you have very few instances in a matrix of possibilities, it leads to machine learning, in essence, overfitting the model and coming up with some very bad conclusions. It's something that it only sees a few times but sees a strong correlation. It's not enough information. So you need to make sure that you do have a matrix of strong outcomes and strong possibilities in order to conclude what you need to do. So these are just some simple examples, but these are probably the major ones that we've seen in the past. If you look at the roadmap of kind of where people have gone and are going, this is a variation off of some charts that Gartner uses to explain some of the different areas, and I find it particularly helpful to explain and understand why machine learning is important. If you look at machine learning and analytics in general as an overall topic, there has been a progression of advances in this area. However, there is a last area that you're going to see up here, which is to us the most important, which is the concept of system analytics. And at that underlying concept is it's a system or a model of behavior, and that's what machine learning is looking for. You can do a lot of different analysis and analytics as you go through, from figuring out what happened in the past, what will happen in the future, but what you're really trying to understand is this hidden pattern and this linkage that says these things are important. And the reason why it's called system analytics is trying to understand the underlying system. If we applied it to probably retail, we probably would have called it either behavioral analytics or customer analytics, to understand why does the customer do certain things in certain areas. Let me explain a little bit more, and then we'll talk about why machine learning does a good job at understanding the underlying system. Most retail data, if we look at it, has a very interesting and varied pattern. If you look at the top line here, you're going to see raw consumer demand usually is quite varied over time. What we're trying to derive in most instances is get something that we can explain and understand what is a baseline demand pattern. Most ways of traditional ways of looking at retail, we would look at that raw consumer demand and we would explain the patterns that we can understand. And most of them are fairly standard in terms of price, promotion, seasonality, substitutability, etc. However, any time that you look at retail data, there is always what you see in green below, which is some remaining variation that you cannot explain. Typically inside of forecasting and analytics language, this is called error. But we would argue it's really unexplained. It's deviation and it's risk and it's unexplained behavior. And I think that the core of what we're trying to get to with machine language is trying to get to that last part below, is to being able to explain these deviations, errors, variations that we cannot explain through traditional techniques. I'm going to take you through an example in just a second of how you might be able to look at that. So here's a real-world example. The product category is automotive tires. Machine learning techniques basically found that there was a correlation between inventory position and demand. So in other words, if you looked at the perpetual inventory at each quote-unquote demand location, and then you looked at demand, you'd find that there actually was a correlation between those two. The modeling underneath it that then you start to peel apart was that the predominant values of the inventory positions in the correlation to demand were, as you might expect, us being human beings and understanding that the underlying system is a car. It has 4 wheels. And because of that, the predominant and most important numbers in terms of inventory position is 4, 3, 2, and 1. But as you start to build out the model and understand the correlation between those two, you want to explain what is the demand at each of those different values, and how would that correlate to building a longer-term predictive model. So what we do within that is look at the machine learning, then look at the model that it produces, and the model that it produces you would say is a correlation between inventory position and demand. Internally, we would call that a tiered lost sales model, and then improve upon it to indicate what would happen to demand if you only had 2 tires versus 4. You can see it in this actual example, and improve that model as it goes through. A couple of key concepts inside of this. Number one, machine learning to actually uncover what is the correlation, what is the model which is there. The second is to put an analytics person or an analytics team on it to then explain the model to connect it into retail. Because at the end of the day, even though this is being defined by machine learning and defined as what is going on in terms of the underlying system, you then have to connect it to operational use, and you then have to decide what are you going to do at retail with this information. That connection and how you actually output and use the information is, in essence, the last mile of machine learning, but as critically important as the underlying learning is understanding how to use it. With that, I'm going to pass it off to Stefano, and he's going to walk through some more advanced concepts of machine learning techniques.
Thank you, Kevin. So machine learning being an umbrella term that covers a number of techniques, or actually group of techniques, and then within each group we have many small sub-flavors. I think it'd be interesting to scan some of those techniques or group of techniques and then provide a small sample of possible applications in the retail context. And in that spirit, probably the two most iconic applications that come, one from unsupervised learning and one from supervised learning. The first being clustering, and there are very many flavors of clustering. K-means being one of those, one of the most popular, that allows us to, given a population of individuals, clustering allows us to group that population into two or more subgroups that have a higher degree of homogeneity or similarity within groups than there are across groups. There is an almost uncountable number of applications in retail of clustering. Common ones are seasonality creation, looking for similar patterns of demand across different products over time. Store clustering, grouping stores that have similar response to specific demand characteristics, and so forth. And the other example that falls under the subcategory of supervised learning is regression. Again, that also comes in a variety of flavors. Log linear regression has proved itself to be very useful and performant when predicting responses, how demand responds to price changes. Yeah. Going through this list, we have more or less esoteric or everyday techniques. Random forest is sometimes comes in useful when we have highly attributed driven data, which is very typical in retail with classic applications, useful applications in assortment optimization, for example, that is highly driven by attributes. Another flavor of regression is multivariate regression that helps us understand the response of demand to not just price changes, but a variety of promotional vehicles. Might be in-store positioning, in-store signage, circulars, ads, and so forth. Then we have the classification branch. This also is supervised learning. We found that it's very useful and performs quite well when trying to determine when an observation is representative of the underlying demand process and when instead it's an outlier that should be filtered out. And filtering out outliers is a big challenge in retail and forecasting because it has to do with not interpreting noise or spurious observations as characteristics of the very demand process we're trying to describe, if they're not. Then we have the ever ubiquitous neural networks that have proven to be quite useful in augmenting time series models for forecasting in the presence of one or more causal demand factors, demand drivers. Lastly, let me mention one more flavor of clustering, divisive clustering, that is particularly useful for seasonality creation, especially for short life cycle products. In general, one of the main goals or purposes of machine learning is to identify what we call features of the model. The features are the drivers, or what used to be called explanatory variables. A good machine learning model has to be able to identify the features in a very robust way and predictive way. So let's look at a roadmap on how to apply machine learning in a way that it actually is aligned with the goals of the organization. And speaking of that, the very first step, and we call it step 0 because it's an Uber step, if you will, is before we apply any machine learning, we really have to be able to ask the right questions. And these are always business questions. What are we trying to achieve? It's a little bit like asking, where do you want to go? And then apply machine learning to determine how you want to get there. Of course, knowing which direction where you want to go is paramount in being able to get anywhere. So once we have the right business question asked, then there is the non-glorious work of collecting and cleaning the data that Kevin mentioned earlier. It's non-glorious because it's not a fun component of this roadmap, but it's a necessary step. And we all feel the urge of doing the fun stuff first, which is to apply the machine learning, the regression, all the different models. Unfortunately, those only work if there is an underlying bedrock of good usable data. And much like chocolate can be spelled in 10 different ways, sometimes we have automated ways to clean up the data. Sometimes it's just manual labor that needs to be thrown at it before we can reap some benefits from applying machine learning. And in terms of data, a very well-established paradigm of machine learning is that the more data, the better. And of course, in retail, which is a prodigious factory of data, history allows us to accumulate more data over time. And for as long as the history we're accumulating is relevant to the existing business environment, we should retain it so that we have more data to train the model and validate the model on. Once we have those two necessary components, basically a vast amount of good, clean data, this is when we can start thinking machine learning. What models are most appropriate to achieve the goal that we have set up with? And it most often involves, I would say always involves, a number of iterations. The iterations are necessary to enhance, to make sure we have the right model selected, and then validation is also a very important step in machine learning. Knowing how to split the data between training, which is basically calibrating the model, and then validating the model is something that, even though there are general guidelines, the specifics really depend from instance to instance, and experience there really goes a long way in guiding the application of machine learning. When we have something that we think it works, we now have to make the return leg in the round trip from business to math to business. So injecting that math finding back into the business, which requires a very thorough assessment of, are we answering the right question, and is the way we're answering the question profitable for the organization? And basically this is a trade-off, or assessment, I should say, of risk versus opportunity, because it is somewhat tempting to say, well, that's what the math says, so it must be good, and maybe underestimating factors that may otherwise advise us to either use a different model or to apply the model eventually in the business context in a different manner. So it's a caveat that should be heeded to when applying machine learning and bring them to fruition. This is one of my favorite quotes from Andrew Ng about machine learning, that so much time is usually spent refining the model to the nth degree, even for small marginal improvements, where probably much better performance will be obtained if we just spend more time accumulating more data. And as Andrew says, a good model trained on a large amount of data will always beat a better model trained on a small amount of data. And this is a truism in machine learning. Finally, going back to step 0 of the roadmap is, why are we applying machine learning to begin with? yes, there may be different questions, business questions you're trying to answer, but eventually there's always one ultimate goal, which is to enhance, improve profitability. And being able to tie the final objective of improve profitability to the specific levers that can be affected by applying machine learning is probably critical to ensuring a successful application of machine learning to the organization.
Thank you so much, Kevin and Stefano. And you've shared a lot of great detailed information about machine learning, a lot of great insights and suggestions. I know we have some questions that have come in. Before we begin the Q&A, I just want to remind the audience to please share your feedback on this session and the entire webinar series by taking the quick survey. And again, there's two ways to take it, by clicking on the icon circled here or waiting until the session concludes, and it'll launch automatically. Thanks again for your feedback in advance. So we're ready to start Q&A with both Kevin and Stefano. And we have received some questions from the attendees, so I'm going to get right to them. And Kevin and Stefano, you can jump in, whichever one should answer each question. So the first question is kind of a high-level question. What advice would you give to retailers who are looking to employ more advanced analytics?
So Kevin, let me take that. And at the risk of repeating myself, I think the number one advice I would give is to make sure we're asking the right questions, the right business questions. Make sure that we are tying the profitability objectives to the specific levers that we're going to affect with machine learning, and then ultimately, obviously, do a good job in the machine learning department, making sure that we have lots of good data and a decent to good or better model.
All right, fantastic. Thank you. So kind of a follow-up question to that, and the question is, do I need to have big data in order to use machine learning?
Yeah, let me jump in on that one. I think, first off, big data is something everybody talks about, but there's no clear definition. And as we said at the outset, the core of machine learning is this concept that behind data there's a relatively simple model with a small number of important factors that have interaction. So the amount of data in and of itself does not have to be big, as the reality is most retail data is fairly large. But it does need to have the important information in a clean and usable format through which you can see that relatively simple model and have those factors that are there. What makes it most useful is when there is a pattern to the data that a human either cannot easily detect or would take them an awful long time to dig through and find it.
Great. Yeah, thanks for clarifying that, because I know there are a lot of different ideas about what big data means. So thank you for clarifying. Another clarification I think that a lot of the attendees might need is, and here's the next question, what is the difference between machine learning and optimization?
Well, that's exactly the sweet spot here for our machine learning and optimization. A good way of looking at it is machine learning provides the information or better information needed to perform the optimization. So whether we're talking about inventory optimization, price optimization, logistic optimization, those are all optimization models that take inputs. And the inputs, the better the inputs, of course, the better the outputs. And the quality of the inputs is what machine learning is supposed to do, to provide better inputs, whether it's a forecast, it's a demand, pattern, if it's a correlation, it's a grouping. Those are the ingredients, if you will, better ingredients that go into the optimization recipe that eventually is the one that will allow us to tie the better information coming out of machine learning models to the higher profitability in whatever part of the organization we're applying this process to.
All right, thank you. Okay, another great question, and there are a lot of acronyms being thrown around the retail industry right now. One of them is artificial intelligence, or AI. This question is, how would you explain the difference between machine learning and artificial intelligence?
Yeah, based on the fact that I've got quite a few years of experience in this, I could tell you the reality is artificial intelligence has been around for probably in excess of 30 to 40 years. And so machine learning is considered a subset of artificial intelligence. If you looked at artificial intelligence systems, many of them historically had been built with kind of real-time little data, but with a large amount of expert input. So in other branches, expert systems as an example. So machine learning in particular, as it relates to retail, is the concept that machine learning can use information to create the models that are predictive, although you're going to see a lot of things out there in terms of in the future with, vehicles that are self-driving, et cetera, that are all artificial intelligence systems, but are not necessarily machine learning systems.
It's all very fascinating. And so you mentioned predictive in your response, and there's the next question kind of addresses that to some degree. And the question is, if machine learning is used mostly for predictive analytics in retail, then what techniques can be used to provide prescriptive analytics?
This is a very good question that actually it ties back to the previous question about machine learning optimization. Because if we look at predictive analytics as being able to tell us what's going to happen, then prescriptive analytics is what we need to affect the change that we want to see. Again, it goes back to profitability. How do we improve profitability? For example, inventory optimization. The optimization part is part of the prescriptive analytics, but it's fed with better information that comes from predictive analytics, such as demand. How will demand respond to different modifiers, such as price, promotions, or other type of promotions? So it's really a two-step process. The predictive tells us what's going to happen, and then based on what's going to happen and how demand reacts to different drivers, then we affect the drivers to achieve the desired result, which is the prescriptive part of the process.
Okay. Yeah, and I think this next question is a follow-up to that, or a clarification. And the question is, it looks like prescriptive analytics can be used for decision support or decision automation. What's the difference there?
So one way that we like to think of the difference between decision support and decision automation is when we have a small number of large decisions. Usually, humans want to retain some degree of independence when making the final call, and that's why decision support is more useful in that context. Whereas when we have a large number of small decisions, humans cannot or don't necessarily want to micromanage everyone, and they're more willing to trust not just a recommendation system, but an automation system. Let me give you an example to clarify. Markdown optimization. There are instances where the retailer is able and willing to execute markdowns at the SKU store level, possibly even every week or almost every week. And for a large retailer, that can be hundreds of thousands of decisions over the course of a season. And in that context, decision automation is, or markdown optimization in this case, is most recommended. Whereas a retailer that has a smaller SKU count executes markdowns maybe at a pattern or style level and chain-wide, not store-specific, and only with a particular cadence of 2 or 3 times in a season. Instead of having hundreds of thousands of decisions, they probably only have hundreds, at most 1,000 decisions, which have each of those decisions has a larger impact on profitability. So while we may want to offer up all the necessary information to make a better decision, most likely the user still wants to retain the prerogative to make that ultimate decision. And this is probably a good way of thinking of the dichotomy between decision support and decision automation, and how prescriptive analytics feeds into both.
And I think it will be comforting for a lot of retail executives to know that, the machines aren't going to come in and just take over all of their decisions. Or they can in some cases where it's appropriate, but it's also a good mix of, human decisions and machine recommendations at the same time. So I think, knowing a lot of the, retail executives who have been in the industry for a long time, I think that it's comforting for them to know that, I think.
Yes.
Okay, so I think we have time for one more question, and then I just want to remind our attendees that please, if you have other questions, submit them, and then our speakers can follow up with you after the presentation. So let's just get to this last question, and it is, advanced analytics takes into account factors that have never been considered. So given that fact, how can the results be validated?
It's a great question, because this is one of those that goes back to kind of your last comment, Debbie. I think typically when you think of it this way, the machine learning is going to come out with a model. So when we're talking about factors that haven't been considered, what comes out is a model of predicted behavior. The first thing that typically we do is you then back check it through time. And if you find that model back check through time has a high level of correlation to expected behavior and output, the next step typically that we would use is to actually use it in a pre-post test control evaluation. So in other words, try it, but try it on a limited basis, and try it on something that is distinctive enough to where you can read the outcome and read whether or not it really did do what you thought it did without noise. And we at 4R actually have a variety of systems we use to make sure once the models are built that we can actually look at them in a very clean pilot environment with pre-post test control. And that way you can determine their effectiveness before you decide to apply those learnings on a broader basis.
Right. Again, that comfort level, and so it's great to know that there's a test and learn built into the whole process. I think again, comforting for a lot of retail executives. So thank you to Kevin and Stefano. You've shared a lot of great insights, a lot of great advice, some fantastic examples. I'm sure that there are more questions to come, but for now we're going to wrap up for today. Again, thank Kevin and Stefano, and thank all of you for attending this session. I'm sure, again, it stirred up a lot of different questions and ideas, and please feel free to submit your questions, and our speakers will reach out to you. So we hope now that you'll join us for our next presentation, which is today at 2 p.m. Eastern Time, and it's called In-Store Mapping to Drive Customer Engagement. So that's, again, at 2 p.m. Today, Eastern Time. Until then, thanks again to all of you for joining us, and enjoy the rest of your day.